Hello everyone, welcome to problem solving tutorial. This is me Mahir. Today we will be learning BigMod algorithm. So what is BigMod algorithm? Say we are given B, P and M, three integers as input. Integers are, well, we are given three numbers P, P and M. We need to find out the value of P to the power P mod M. So at first sight it seems pretty easy, right? That P to the power P mod M, there is a built-in function called pow in C and C++. There is also a similar method in Java that we can use to find the value of something to the power something, and mod is just a basic operator in the programming languages that we use. Then where's the problem? Well, the problem happens when the value of P and P is large. If value of P and P is large enough to exceed the limit of integer data type, also of long data type, then what happens is that memory overflow occurs. So how can we get rid of that? Well, for that, we will be learning this BigMod algorithm. So before jumping right into the algorithm, let's learn few tricks that will come handy while during learning the algorithm. One thing is that we need to learn A into B mod M is equivalent to A mod M into B mod M whole mod M. That means if we want to find the value of multiplication of value of A into B mod M, we can get the same value by first modding A and B individually by M, and then multiplying them, and after that modding the multiplication result by M again. So this will come in use in future when we are going to learn our main BigMod algorithm. So now let's learn another technique that we will be using. So let's keep this here. So well, another technique that we are going to use is, say we are given B to the power M. We will split this B to the power M in two parts. So what will be those parts? If P is even, that is, if P can be represented by 2k, where k is any integer whose double is P, then B to the power P can be divided into two halves, P to the power P by 2, and another part is P to the power P by 2. So if we multiply this P to the power P by 2 into P to the power P by 2, we will get P to the power P. That is the original number. Okay, so what happens when P is not even, that when P is odd? Well, in that case, when P is odd, P can be represented by 2k plus 1, where k is any number, k is a number whose double is 1 less than P. That means 2k plus 1 is P. How we can divide this in two parts? Well, to do that, we will split it in two parts. In one part there will be b to the power 1, this one, and another part is b to the power 2k, where 2k is actually p minus 1. Means this is basically p minus 1. Well, if we take this one from right hand side to left hand side, we will be getting p minus 1 equal 2k. Means in place of 2k we can write p minus 1. So if p is even number, then we will split b to the power p in b to the power p by 2 and b to the power p by 2. And if p is odd, then we will split it in two parts, b to the power 1 and b to the power p minus 1. So why are we doing this splitting? Well, after splitting these parts, the main number, we will apply mod m operation on each of those subparts. Then we will multiply those modded results, and we will then again multiply the result by mod that result by m. That means if you look at this equation, we can compare that well. In this case, b to the power p is equivalent to a into b. That means b to the power p by 2 into b to the power p by 2. In place of a and b, there is b to the power p by 2 and b to the power p by 2. Then what we will be doing is, we will at first mod b to the power p by 2 mod m, and then we will find out b to the power p by 2 mod m. Then we will multiply those results, and after that we will mod that again by m. Same goes for the case when p is odd number. In this case, in place of a there will be b to the power 1, and in place of a there will be b to the power 1, and in place of b there will be b to the power p minus 1. We'll mod each of them by m, and then we will multiply them, and then we will mod the multiplied result by m. So this is the technique that we are going to use to find the value of b to the power p mod m. So how long? Well, another thing is, after we split b to the power p in two parts, b to the power p by 2 and b to the power p by 2, what will we do? Well, we are doing this because p and b can be too large. So what if p by 2 and p by 2 is also large? The solution is, we will keep doing this splitting until we find 0 as p. That means let's explain that with an example. Say we want to find the value of b to the power, say 8. So we'll split it in two parts, b to the power 4 and b to the power 4. Then we will split each b to the power 4 in b to the power 2, b to the power 2, b to the power 2, and b to the power 2. Then we will split each of these b to the power 2's in b to the power 1, b to the power 1. Well, I should have just gone with b to the power 2, I guess. It's getting large. Well, I hope you get the point. We will keep dividing the p by 2 until we get 0. So when p becomes 1, it's an odd number. So we will split. Let's do this with b to the power 1. Split it in two parts, b to the power 1 and b to the power p minus 1. That is 1 minus 1, and that is 0. Okay. So when we get 0, we will stop right there. So how do we solve this problem? Okay. So this is the basic concept of BigMod. So we will, at first we will get B, P and M, then we will keep splitting B to the power P in two parts. If P is an odd number, then we will split it in B and B to the power P minus 1. If P is an even number, then we will split it in two parts, B to the power P by 2 and B to the power P by 2. We will do this recursively. We'll keep splitting them until we get value of 0 as value of P. And after splitting B to the power P in two parts, we will mod each of them by M, and then we will multiply them, and then we will mod the multiplied result by M. Okay, so let's get into coding. Okay. So let's see how we implement that concept in code. At first we will take 3 numbers as input. Then we will just print, well, we will do all these BigMod work in a function called BigMod. It will naturally have 3 parameters, B, P and M. And here we will just print the value of BigMod B, P, M. Here P is, we want to find the value of B to the power P mod M. So what will we do in this BigMod function? Well, like I said, we will do recursion. We have to use recursion. When P is 1, since we will be doing the same thing. Well, when we split B to the power P in 2 halves, B to the power P by 2 and B to the power P by 2, we will be doing the same splitting work on both of those, B to the power P by 2 and B to the power P by 2. So naturally we'll be needing recursion in order to do that. So, like we said earlier, there are 2 cases when P is even and when P is odd. So when P is odd, what will we do? We will be returning, well, like we said, we will be then returning, well, okay. Okay, so when P is odd, then we will be splitting B to the power P in 2 parts, B to B and B to the power P minus 1. Then we will mod each of those parts by M, then we will multiply those results and then multiply the final result by, mod the final result by M. So let's name the first part as part 1, which will be B, the normal B. In part 2, what will be there? There will be the value of BigMod B P minus 1 M. This is where recursion takes over. What is happening here is actually, at first, sorry, in part 1, when P is an odd number, at first we will split b to the power p in two parts, p and b to the power p minus 1. And since b to the power p minus 1 is not 0 yet, so we will be doing the same splitting work on that. In order to do that, we will pass b, p minus 1 and m in BigMod function again, recursively. The result will, let's think about the result later. We just know that we had b, p and m as initial inputs, and we will be splitting the b, p and m in b and b and b in b to the power 1 and b to the power p minus 1 part. And we will do the same work on b to the power p minus 1. So we are passing b, p minus 1 and m again on the function. Okay, so like I said, what we will be doing now is modding each of part 1 and part 2 by m and multiplying them, and then again mod the multiplied result by m. So let's do the modding part here. We will mod b by m and then store it in part 1. Now we can do the same thing here on part 2, modding the second part by m. But well, this is not actually necessary, since BigMod function actually returns a result which is b to the power p mod m. So this will definitely be less than m, so we don't need to mod it by m again. So in part 1 we will be having b to the power b mod m, and in part 2 we will be having b, p minus 1 and m as parameter of BigMod. So we will just multiply this part 1 and part 2 and then again mod it by m. So this is the thing we will be doing for the case when p is on. So what do we do when p is even? So if p is even, then we split b to the power p in two halves. In one part there is p by 2. So what we will do is we will split, since p is even, so we will split b to the power p in two halves. In one half there will be p by 2, and second half there will be BigMod b, p by 2 m. So we will split the original function for calling in two parts. In one part there will be p by 2, another part there will be p by 2. So since both of them are same, so let's just keep it in single variable. Now what we will be doing is returning the value of half 1 into half 1 mod m, same as this. So now we have done the work for the cases when p is odd and when p is even. So when do we stop this recursive calling? We do that when p is 0. We know that if p is 0, then b to the power 0 is actually 1. So since b to the power p is 1, so we can just return 1 for the case when p is 0. So we will keep, so let's just recap what we have done here. At first, we're taking 3 numbers as input, and then we are passing those 3 numbers as parameter of BigMod function. In BigMod function, At first we're checking if P is 0 or not. If it's 0, then we will just return 1. If it's not, then we will check if it's even or odd. If it's odd, then we will split b to the power p mod m in two parts. In one part there will be p mod m, in another part there will be b to the power p minus 1 mod m. That means big mod b p minus 1 m. Then we will return the multiplication of those parts mod m. And if p is even, then we will split the two b to the power p mod m in two parts, b to the power p by 2 mod m and b to the power p by 2 mod m. Since they are same, we are keeping it the same variable, then we are multiplying those parts and modding them by m. So now that we have written the code, let's check if it gives correct answer. Well, if we take, let's check it with small number. If we take 7 as p and 2 as p, that means 7 to the power 2 is 49, and then if we mod it by 42, then it should be returning 49 minus 42, that is 7, and it's returning correctly. So let's check for larger numbers. Let's say 89, 14. It's a huge number. Then we will mod it by, say, 2589. It returns. Well, I have forgotten what I have used as B, P, and M. 89 to the power 14. Let's do one thing at a time. 89 and 14, and we will mod it by 4896. So 4896, and we are getting 3025 is the output. Well, it matches. So I guess our code works. Okay. So that's all for today, for this tutorial. Thanks for watching.